Thank you so much for joining us today. I am Rebecca Marshburn, and I'm a marketing lead and event coordinator here at ResolveAI. We build AI for prod that helps you resolve incidents faster in code with production context. Conveniently, that is what our guests are here to talk about today. Josh Gross is a founding team member focused on customer and developer success. And Angelo Marletta, who is our special guest speaker, is a staff engineer at Coinbase who has transformed from an AI skeptic to an AI believer with an emphasis on human accountability. So when we prepped for this session, Angelo said about AI, it is not magic, it is not sorcery, it is a tool. So he's going to cover how his teams use AI as a tool to increase their leverage and productivity as engineers. A few notes before we get started. We'll record this session to share it with all of you and those who couldn't make it. I'll also be posting some poll questions throughout the session. And we have two team members in the chat. Thank you, Manveer and Prodon, who will be here to answer any questions and moderate as needed. And at the end of the session, Angelo is happy to take your questions as well. And Josh and Angelo will be tag teaming like an open fireside chat. So with that, I'm excited to say, Josh, I pass it to you. Let's begin.
Awesome. Thank you very much, Rebecca. Let's get started. So before we jump in, I do want to show you the product so you can see how we've put agentic AI to use for this use case. How did we get here in the first place? Well, the general theory or consensus is that coding and production, if you're an engineer, you're spending about 50% in each. But what we're starting to find and what a number of studies have shown us is it's just not true. In fact, only about 16% of an engineer's time is spent actually coding. And I think that number's dropping. And you saw, I believe, the CEO of Cursor recently, they acquired Graphite, and they said, you know what, like, hey, great, we're shipping all this code, but now we're realizing that code reviews are actually taking longer. And so now we need to use AI for that too. And so the equation really looks quite a bit different. A lot of the time that an engineer is spending is what we're calling toil, which is not actually writing the code. In fact, I think that coding is decreasing because a lot of that is being written by AI. Now we're seeing coding reviews take longer, understanding what the code is doing in production, debugging, and the amount of people that are engaged in that process, it's growing exponentially. And I think we're even at the onset of that wave. We haven't even seen it truly hit yet. And the reason being is when you think about it, if you were to look at production and all of the tools, this proliferation of tools that your teams are using, each of those live kind of in a silo. Like they have their own interfaces, you have your own expertise throughout your organization. But even if you were just take a scenario like an incident and think about all the code switching, so those tabs, the number of CLIs that you have open, and what data you're trying to access from each, and what data you have accessible based on your zero trust networks and so forth, it becomes very, very challenging. In fact, I would wager to say that there's probably like hundreds more components per individual engineer that you have, whether it's between the tools, if you are running containerized ecosystem, the number of libraries and so forth. And so just the amount of fragmentation that you have, and it's not getting any smaller. And so it makes it very, very difficult for humans to navigate it all. Additionally, like if you take an incident specifically, um, by default, you have expertise locked in people's heads and groups throughout your organization. And so when you think about like any type of incident that occurs, usually it's going to require at least more than one person. And a lot of times, especially in these like hybrid infrastructure environments with silos of platform teams, application teams, database teams, and so forth, it requires the navigation of these communication or these silos of information just to get to RCA or root cause. What's fascinating is as we've been building eval sets and working with our customers, a lot of the time you're not even getting to root cause. You're really just doing mitigation. And so that information that lives in each of these individuals' heads, it requires more people to get involved. But here's where the crux of the issue is, and we're seeing these articles fly around context graphs, is that in production systems, most of the context that you need is not documented or it is stale. So there's the concepts of runbooks, SOPs, there's the synchronous communication that happens in your collaboration tools. All of this lives either it's not written down or it is, but it's located in places that's inaccessible and definitely not usable during the time of like an incident. And so what ends up happening is you've got like these three, I would say, compounding problems around like there's too many tools and too many components in your environment. There's too many silos of information and expertise, and then there's all this undocumented information. And so it just makes incidents really hard. And in fact, it makes any type of question you have about your production system harder to get an answer to. And so it's just going to get worse, especially with these AI tools. And so we start to see that like the complexity is increasing, the velocity of change, and the length of PRs that are being created right now, especially if you're not doing like your markdown files and so forth. The tooling itself, it's super easy to turn on a CLI tool, get something into your IDE, and it's just becoming more fragmented. And then, of course, like the knowledge gaps, we haven't found a solution yet today. And so let's propose how Resolve is solving this. I want to show you that how it works as well, and then we're going to pass it to Angelo. So we're calling this AI for prod. It started as AI SRE, and a lot of that is because somehow we've conflated SRE with incidents themselves. And so it became a manifestation of how do we solve that problem? Well, we get great SREs in there, and they're doing incidents and root cause and so forth. But what it takes is something very, very interesting to actually build something that can do incident analysis and root cause. The first thing that is required is that expertise, that domain expertise. Like LLMs are great at a lot of things, but to be able to troubleshoot databases as well as like correlating code and PRs across the production systems, so your telemetry data and so forth, it takes a lot of expertise. So a lot of training and tuning and knowledge so that how you interpret these various sets of data. Okay. The second piece, which is really fascinating, coming from an observability background, is say you have 100 engineers, there's probably only about 6 engineers that are actually really good at tools, like experts in your Datadog know how to generate or craft the perfect Splunk query. Now, agents and AI is actually really good at doing that. And then finally, this is one that it's taste, it's magic. It's also a lot of UX is how do we capture that tribal knowledge that engineers aren't really incentivized to give up? Meaning like nobody wants to do documentation. And sometimes that documentation couldn't be created by humans anyways. And so what we've built with Resolve is a system that does all three things. So the first thing that we do is we built this series of agents. And now as you see, like AI is evolving, there's background agents, skills agents, and so forth, orchestration. But these agents, they plug into your existing infrastructure. Your existing infrastructure being like your AWS, your Kubernetes. If you are running Kubernetes, we actually have a lot of customers that are even on bare metal running their own data centers. Your telemetry tools, your code gen, any SOPs or run books. And it uses this data in a very organic way. And I'm going to show you how in 1 second. So today, when we think about how a tool like Resolve that's plugged into all of these tools or all of these systems works is incidents. We think about incidents because everybody within your chain has dealt with them. However, by plugging into these tools and generating that context and learning about your systems, there's a lot more that you can do with it. Interestingly enough, there's two interfaces with Resolve I'm going to show you in a second. But what it enables people to do is not just deal with alerts. It's everything from refactors or why is this migration having issues? What are my security policies and so forth. So let's jump in. By the way, we're working with customers that probably look very similar to you, everything from 30-person engineering teams that are all cloud native and AI centric to your largest financials in the world. All right, so let's jump in. Move all of my Zoom windows. And let's get started. So I'm going to start with just kind of like the basics of Resolve, which is once you have these integrations in place. So let's start with the integrations themselves. What we do is we build what's called a knowledge graph. This knowledge graph is a temporal understanding of the dependencies and the relationships between your systems. Because when you think about like an incident or any issue that your team is facing, It starts with a symptom that's isolated to a certain area in your application. And this is not really meant for human consumption. This is actually just a demo app, and you can see the complexity or all the different components that are related in here. Well, if something occurs, say, on the front end, which is the application in here, the first thing that you would do as a human is you'd want to understand, okay, like what is the front end actually connected to? How is the health of that? And then you'd start to branch out your investigation. And so Resolve naturally, or out of the box, we create this for you. And the reason being is because it's really, really important to get away from, say, correlation. And so these are some of the components that we're using. These are the components so that we understand the entities, the environments, so that we can generate really specific queries so we can exploit the data rather than explore and, of course, overwhelm infrastructure, but also, again, get to correlation, which isn't necessarily the goal here. And so let's see what you can do with this information. So I'm going to start real quickly with the chat just to show you how the natural language works using these integrations. And then I want to take you into an investigation. So say I just started here at Resolve. Tell me about my AWS infrastructure format as a table. Okay. So if I came in and I wanted to know about what we're running in infrastructure, one, I definitely need all the IAM rules and so forth. But two, I need to understand AWS CLI. And then I need to know how to navigate that as well. And so with Resolve, as a new engineer coming in, it's very, very simple to start to answer questions that would typically be a distraction for a human, meaning going into that Slack channel and the Ask Engineering channel and saying, hey, can I ask this question that may sound a little bit dumb, or walking over and interrupting somebody. That's really like when I think of the value that Resolve is providing for our customers today, it is that distraction avoidance. Now, sometimes distractions, of course, are incidents. Now, here, what we're starting to see is what Resolve did is it goes and it uses AWS CLI for this use case. It starts to fetch all the information, and now we're starting to see it print. So here you see all the EC2 instances, S3 buckets, RDS. We give you all the source data, where this is coming from, and the key observations. Well, when I ran this earlier today, I started the same process, okay? I want to take you a little bit through what that looks like, though, and how organic and natural this conversation can be. One of my customers, just the other day, they were going through an ECS to EKS migration, and the application that they're running started to perform differently. They started a very similar type of chat as what you're seeing here. Now, when you see something like this, you say, okay, here's everything that's running in here. My natural engineering curiosity tells me, okay, well, what are we using RDS for? Can you draw a mermaid diagram? Okay, so now you're seeing the flexibility of our platform and what we can enable. So here we see what is RDS used for, using the integration. So building this dependency map using things like tracing, traffic data, Kubernetes data, even CMDBs. We also use like JSON files for some of our customers as well. We're able to create these diagrams. These are probably going to replace all of those manual diagrams you're creating in slides today. Now you can see, once you start to see RDS, maybe I want to understand the baselines. And so just doing this, you need to find that dashboard that exists on. You need to understand what like normal looks like. You need to understand the business and why, say, your RDS load may increase. With Resolve and using these agents, we can do that all for you. And so here, I'm interested in health metrics. Can you share performance insights, highlighting any anomalies, spikes over the last 24 hours? So there's got to be some ML that's going to allow us to know that, hey, these are anomalies. And so the first thing that we do is we identify the dashboards and the charts that are relevant. Now, some of this happens automatically. So right when you hook up Resolve to your Datadog, we're going to discover the charts and dashboards and the metrics that are available to us. And we're going to start to, rather than just explore, we're going to try and exploit or use those resources, metrics that are most important or relevant for these use cases. And so we're going to take you right into those specific charts, those dashboards that are used, the storage base, etc. And now we can start to see what it's producing. So here we see the RDS performance insights, last 24 hours, any anomalies. critical anomalies that are detected, and all of this is cited, okay? So you can go right to the data sources. Here we're seeing the throughput spikes, baselines, that we generate these charts with all the metrics. And again, we're not going in and re-ingesting all this data. We're just accessing it at runtime. Now we can start going into, can you look into the CPU anomaly spikes? And now we're getting into the investigations. And so you see how this unfurls. And a lot of time that I see during the day when like our team is using Resolve as well as our customers is people are just getting these tickets that have an error in them and they don't have time. So it shoots into the backlog. And instead they're just putting that error right into Resolve and saying, you go do this while I'm still, say, working on something else. What I want to do though is when we look through, say, this investigation, you're starting to see that there are issues with RDS. And with these issues, we can take you all the way to a PR to fix this, okay, with a diff. And now you're starting to see that closed loop rather that human in the loop resolution. We've had these same problems happen in our own production environment. This was a tricky one, and I know I've only got about 2 minutes, but I want to take you through like how sophisticated, once I log into the right, 1 second. Let me log in to my, there we go. All right, so now I'm logged in. This is a scenario that we face in our engineering environment. So we ran into Postgres deadlocks recently. This was pretty tricky because the code that caused it was shipped on a Friday and it required a scale-up event to hit the problem. But I want to just show you kind of the logic and the reasoning and the capabilities behind Resolve. So we talked a little bit about getting that knowledge from humans, that tribal knowledge into Resolve. We build that implicitly based on the interactions, based on being a part of incidents as well. But you can also add this knowledge explicitly based on a team construct. And so when we start to make a plan around how are we going to troubleshoot or answer our question, we're trying to figure out, should we do some deep research or should we go and fetch something very quickly for you? And we use these run books and these artifacts or this knowledge to do so. Then we generate the metrics because what happens is we really want to understand, okay, when this alert fires, these symptoms, when did it start? How high did it go? What all was impacted? And so we start with that initial surface area and we need to uncover what are those metrics that are going to be most valuable in those charts and panels, because we really don't ever want to do something like index equals asterisk or anything where we know that it's going to either A, impact rate limits and performance, but B, it's going to bring in too much information to be processed for the context windows, okay? We went into logs, we looked at the infrastructure graph, so again, that knowledge graph that's created, because what we wanted to figure out is what else could be impacted, what's dependent on this Postgres. Then what we found was, okay, it looks like we understand the symptoms and the issues. Now let's see what could have caused it. And so what happens is we update our plan to start to look at these other tools to fill out those gaps. And so we looked at the code files, additional metrics. We find the TypeScript repos that were necessary. We end up concluding this investigation. Typical investigations, if it is a deep investigation, it can take 10 to 12 minutes, depends on how nested it is. And that's something we can talk about in the answers as well. And what we found was these Postgres issues were actually caused by a code change. The supporting evidence all looks like something like this, okay? Each of these working theories that we create, it's high, medium, low, and we give recommendations on how to prevent this in the future. Here you see the suggested next steps, implement the fix by adding deterministic lock ordering, add the retry logic, and monitor. So again, optimize our monitoring. I'm going to pause there. I want to give the floor to Angelo because he's got that real experience as well at Coinbase, and I know you're here to see that.
Thank you, Josh. Thank you for your presentation. I'm going to, in the next 10, 20 minutes, I'm going to talk about how we have used Resolve in the last few months, how we plan to use it in the future. If okay, everybody can see my screen, I'll go ahead. I am an engineer at Coinbase in the infrastructure team, in particular in observability. And I kind of started as a skeptic in the AI field about in 23. I didn't really believe that it could do much beyond creating some small scripts that you can maybe throw away the next week. But then it turns out that I was wrong, and this technology has a real impact on the industry. It actually accelerate the industry, and ultimately, I believe it can have an impact on economy and society. And so during this journey, I discovered the power of these new tools. So as part of my job, I prevent incidents and lead the response to those incidents, mostly reliability ones. And we'll see how this is related to Resolve. For those who don't know, Coinbase is a cryptocurrency exchange where people can buy, sell, transfer, and store cryptocurrencies like Bitcoin in a user-friendly way. Today, we serve over 120 million users who can trade 40,000 assets for a total value of about $500 billion. So to sustain this business, the infrastructure needed is complex. It's not simple. We went from a big monolith that was not scalable anymore to an infrastructure that is distributed with thousands of microservices that are interconnected with each other with complex interdependencies deployed on hundreds of AWS accounts and Kubernetes clusters. We also have lots of different data stores, use GraphQL, gRPC, different technologies, and really it's difficult to understand the full picture of it. No one really knows the detail about everything, and this is where AI comes to help. Since about 23, I mean the company has decided to embrace new AI tools, from the first rudimentary ones to the more recent that get more and more powerful over time. And today we use them to generate code, to do code reviews, to familiarize with new code base for or new engineers to familiarize with the code base of their team, for linting, summarizing, to find bugs. We use it really for a lot of use cases that revolve around the code. But the code as just as a static entity, not really as running code, and which is where things get more complicated. And so we also had a push from the top to use AI, and I don't have any up-to-date stats to share, but I can say that maybe 90% of the code I write daily, let's say 90% of the code that I push to Git comes from an AI tool. Maybe I do some small amends, but I usually iterate with the agents and then to get to where I want to get. And I think this is mostly the case for most of the people I work with. We really use it for everything. But now that we are writing so much code, basically this is not a bottleneck anymore. We have other bottlenecks now that become visible, and code review is the first one, the most obvious one, as Josh pointed out. And there are other parts that kind of surface as well, like the dev life cycle includes other activities like getting to a consensus of what we need to do. getting approval, getting in for some operation, or do production operation, debugging, deployments. All those things take time. And in the past, engineers used to spend a lot more time writing the code than those things. We didn't really notice them. But one of the things that take time and takes time and affects also users of the service is incidents. Incidents can be frustrating for those who work on them and also for the users who are affected. And so one question we ask ourselves is it possible to use AI similarly to how we use it to create code, to edit code, but on production? In other words, can we ask AI questions like, what is wrong with production today? Why is my service latency elevated? What happened? Why do I see errors or timeouts on this URL? And is it possible? I actually had no idea when I asked this question myself. And you have the right to be skeptic, but it turns out that there's potential, that it is possible for a machine to answer these kind of questions with the right training, with the right context. And so one reason why we decided to explore this space is because incidents take time and can be caused by different things. Usually it's people who make changes and break some products or some feature. But it can also be caused by external events like vendors or network or other things. So there's an actual cost that in productivity, and people getting frustrated because they have to spend time investigating, debugging what is wrong. So how do we make the process of debugging an incident as it's detected faster? Or in other words, how do we resolve this faster? And so this is why we decided, okay, we're gonna start a pilot of Resolve in the company, and let's see what it can do. And the way that we onboarded it was okay. Let's run a test. Let's take a number of recent incidents that affect some part of our engineering infrastructure, and see what the symptom that was observed initially was and what the actual root cause was, and get these two data points for a number of incidents. And then we simulate the scenario in Resolve. So we provide the initial symptom without any hint whatsoever of the root cause, and see what is the thought process, see if it can get to the root cause, or at least how close it can get to the root cause. And another criteria we used in this is that we ran this kind of simulation mimicking an engineer who doesn't have deep domain knowledge, and so doesn't need to enter a lot of information, but it can be vague, like as I said before, like why is my service down at 8 a.m. in the morning today? Because in this way it can be useful to a larger group of people. And then in the cases where it was wrong or incorrect, or maybe couldn't find a root cause, we spent some time investigating why, and whether it was for missing data or missing features, missing context. So basically we trained the agents in in steps, in layers. So the first thing is we gave it access to Kubernetes straight from the Kubernetes clusters and telemetry from Datadog. So these are the only two data sources we used for training. We gave it general knowledge, things that are valid across the company, across all of Coinbase, independent on the product, and then we also entered some specific runbooks that are specific to some products, some services. This was not extensive. It was not a comprehensive of all the services at Coinbase because there's too many. But we picked a few teams that onboarded. And we saw as a result that there was an improvement in efficiency in the time it took to get to the root cause, and that's the primary metric that we wanted to see. How more quickly is the agent able to find the root cause versus how long it took in the real incident investigation. And this is data that we have from the Slack logs that we can compare. And also another criteria was, is it accurate most of the time? If it's accurate most of the time, then it's good. It's a good thing. And it can be improved. The accuracy can be improved by adding more context and data sources. This is what I have observed. So tools like Resolve, they're not going to be like magic that they resolve all your problems with a magic wand. You need to give it some context. The tribal knowledge that Josh was talking about, it needs to be available to the agents in order to have some good answers. And I want to show you, lastly, two example incidents, just to have an idea of what kind of incidents it can debug. This is one that was caused by an internal load test that was a bit too aggressive and took down a service. So Resolve was able to identify what service was overwhelmed, traverse the dependency graph, and understand where the traffic was coming from, and understand that it was actually a load test, because we have taught Resolve how to detect that there is a running load test inside, and it's all a proprietary system. It's not something that Resolve could have known out of the box. It needs to be taught. And a second case was an out-of-memory error in a sidecar container that runs on many different services. So this was had a widespread impact. And in 12 minutes, Resolve was able to find that the problem was an out-of-memory bug, and in real life it took a lot longer than that. Now I don't remember exactly how long, but at least double the time to find what was the problem. And so how do we use Resolve today in practice? So in practice, we use it in two ways. So you can start a thread in Slack and ask questions, or auto investigate. So whenever there's an incident, we automatically create a Resolve investigation. It will do its own investigation in parallel with what engineers are debugging, and and at any time engineers can go to the Resolve UI and see what is the state of the investigation, and see if there's anything useful. In the future, we plan to also allow it to propose remediation to a problem. This is a feature Resolve already has, but we haven't enabled it yet. because there's some technical things to do and to fix, and also security compliance to pass, which I think is already done, but we'll do it in the future. So as a humble prediction, I think in the future these agents will not only identify and find the root cause of problems, but they will take some sort of action on that to remediate the current problem. Initially with the supervision of humans, but then more over time with less and less. Still, someone will be on the loop, but with a, let's say, with a low touch and not with a lot of involvement on the problem. So this is what I think will happen in the next few years. That's all from my side. If you want to connect with me, here's my LinkedIn QR code, or maybe you can see the link on the chat in the Zoom call. And yeah, now I think we can maybe we have some time for chat or Q&A. Josh, what do you think?
Yeah, let's do it. Rebecca, do you want to come on for some questions?
Absolutely. Well, I think that you gentlemen had a few questions that we had covered during our prep session that were pretty meaty.
Actually, I have one question for you, Josh,
Let's do
that
it.
I'm very curious about. I know that you have many customers at Resolve, and some of them are established companies, like my company, but there are also startups and smaller ones.
Yeah.
I was wondering if you see like big differences in how they are using Resolve, if they are like more scared or excited by it, or maybe other things that you have seen.
There's a lot of questions in there. So I've personally onboarded some, to be honest, I think we were surprised as a company by the demand from like larger enterprises, because usually when this is my fourth early stage startup, and usually you're building for like that mid-market kind of cloud native where they have a relatively homogeneous environment, and everything is about just growing the company. But we saw interest from all parties, those with like huge network operation centers where they're just like, hey, we have these L1s that really just look for labels and alerts, and then they escalate them all the way down to these like AI startups. And so we had to really dig in and to understand who does this product work best for. And we found that it's got a lot more flexibility, and that's why this whole AI SRE thing has turned into so much more than that. And I think one unique insight from working with these smaller companies is that the costs of like interruptions, meaning like you're hiring quickly and we all have been there where it's like you're expected to push your first PR on day one, day two, but you can't really go on call for 2-3 months, best case scenario. And like that gap, that is that tribal knowledge, that context gap. And so what we've seen, and I didn't even show it in the demo, is but we use it internally, is like it's just that disruption avoidance, meaning I'll see that maybe a chat doesn't finish or an investigation, it stops a little bit short. Like that would have been an escalation to an engineer. And instead, I'm asking resolve. And so most of the smaller companies, I would say what they're looking for is like self-service. Whether it's like, hey, do this work for me because the product manager is asking for it and I don't really have time for that. Because like if you have a lot of incidents, meaning like Sev 1, Sev 2s, like chances are you're on a code freeze. And so these small companies, they may not have as many customers, or their hygiene, they came in that era of critical user journeys and SLOs. And so it's all about like just speed, avoiding distractions, continuing to innovate. And they're also the ones that are like adding into, say, that resolve MD file / commands and really innovating, or creating webhooks that do proactive investigations before they ship code, just so that they know that everything looks good. And so I'd say that's what I've seen most on from the smaller companies that work with us. On the larger companies, it's everything that you would expect, like similar to what you mentioned at Coinbase, where it's like every new integration requires another security check. And there's a lot more change management, because I saw a question in here around like the PIR process change with Resolve, and like people's jobs are changing. Because there's when you think about it, with a big company, you have such high specialization. And so that means that some of these roles, they need to change in ways because it makes sense to. And so I think there, it's just, you have to prepare an organization. You definitely need more exec sponsorship. Whereas in smaller companies, like easily a principal engineer, or like a junior engineer at a staff level can proliferate this type of technology through their entire organization with very little like change management.
We have some questions from the audience as well. I know that you addressed Misha's a bit with talking about the PIR process. And we
Mm-hmm.
have a question from Carlos, who said sometimes more context makes agents have a big footprint at runtime and results are less precise. How do you manage the ingestion of Kubernetes and telemetry information?
So with Kubernetes, at least in my case, in case of Coinbase, we run an agent provided by Resolve that takes all the inputs and basically reads all the events, what happened in anything that happens in the cluster, and then sends it to the Resolve infrastructure. We don't have specific context added on that, but I understand the question. Like if you overload context, the model can get distracted. And I guess this is a question that I don't really have a good answer for. But when you have a lot of context, I guess. So Resolve has a feature where you can manage teams, and so for each team you can have specialized context that will be used when you investigate problems that are related to that team. So in a way, it's like you're kind of pinpointing, I want you to use these sets of runbooks or context instead of the entirety of context. But there's also a general context that applies to everyone, and obviously that's needed. Is what I mentioned before in one of my slides. For example, how is code pushed? Where the data is for deployments or for load tests or for config change. Those are that is context that needs to be available to everything. But then if you want to add a specific context, you have to make sure it doesn't really pollute every single investigation. That's what I've seen. Maybe Josh has some more.
Yeah, like the context, like, man, I feel like I lived 100 lives in the 2 years that we've been doing this, because sentiment, like this, when you're thinking about building these solutions, or like even building a startup in AI right now, it's the first time in my career where you can't just focus on the problem and your idea of a solution. You have to pay attention to the innovation and the conversations happening outside the building as well. And so this idea of context, like when we started, the context windows weren't large enough for logs. And so how are we going to really get to root cause? And so what we realized though was, in the first 5 minutes of every incident, that's when you just need to pull together the evidence so that it moves people forward and it rules out potential escalations. And so we started like that. Then the context windows get larger, and then you're like, shoot, like why don't I just shove all this stuff into a huge context window and let the LLM do all of the work? Well, like for the last year and a half, the LLMs weren't nearly smart enough. Now, like they're better, but you still run into that correlation problem if you put too much context into these context windows, because then like the non-deterministic nature of it, you're going to get a different answer every single time. And so then you move to the like agentic AI where it's specialized skills agents. And then you have critiquers and LLM as judge. And so now like really where the hard part is, outside of like taste and UX, is it's the orchestration of these agents in the right way to get to the answers. And then you also need to know like when one of these agents times out or when this fails, like how does the orchestrator, or this we call an in planner, come to the right conclusion? Meaning like, do I have enough information? Do I not? And then also like the amount of data that you want to feed in to these agents as well. Like again, the more context, it confuses them and so forth. So like, honestly, this is why building it yourself, we see it, like even when we started talking to Coinbase, like in every company is experimenting with agents for these use cases. What we see is they typically don't get adopted because either the surface area is too small, or the amount of maintenance is higher than it's ever been because you have to keep up with the innovation that's happening.
We have just a couple more minutes. Well, actually, we're a couple minutes over time, but I want to end just with two questions. Aritra and Ali, I promise that we're going to answer your questions likely typed. Justin had a question for Angelo. And so, specifically about the test phase, Angelo, you initially said that you gave it some limited runbooks, but proven impact slide said no source code or runbooks at the bottom. So, can you speak to that? Basically, Justin is asking how many past incidents did you run in your test before you were like, yep, this is the way?
Yes, so we selected 40 incidents that had happened in the recent weeks when we did the experiment. And we did not use any source code, so the agent didn't have any access to the source code, which is it's a big limitation if you do that, because it has a lot less to work with, and you cannot really pinpoint the exact root cause, the exact line that caused the problem. For example, in the out of memory incident, it could tell that there's an out of memory. It could identify the service, could identify when it was when it started, and even the PR responsible for that, because the agent also has access to the kind of the deployment log, but not the actual source code. So if we add source code access, we could get to the next step where it can tell us, hey, this is the line, this is the problem. And maybe, propose a revert or propose a fix. And then engineers would pick one of the two based on something else.
Thank you, Angelo. All right, so let's close out with a favorite question, to kind of leave us buzzing. Do either of you or do each of you have a controversial opinion on AI? Or let's say, what is your hottest take on AI? And let's open it up to that. Really get our blood going before we go to the
You want to
rest of our
go
day,
first, Angelo?
Yeah, you go first, Josh.
I think so. Having lived through enough like purchase cycles in AI already, since we started selling, in the beginning, every purchase was like made on vibes. Then everybody was looking at like Dora core 4 metrics, like how are we increasing our PR frequency and productivity. But like these were all kind of the incentives were kind of gamed quite a bit. I would say like what I've noticed both with Resolve and my own usage of AI is that like we're all doing work that should have been done but never got done because we never had time. And I think like the most controversial thing is we're all anchoring to metrics that we've looked at previously because that's what's known, whereas like the real value of it is being created by all of the creativity and the work that's done now. That wasn't like I see people investigating errors that they never would have had time to look for, which is like preventing issues that are happening. And then so I think it's all these use cases that are evolving that couldn't have been done before, where all the value is being created, more, or at least not all the value, but where more of the value is created. And so we just don't have like a vernacular for it. We don't have the measurements and KPIs, but like it's not captured today in the current models.
Okay, I'll say mine quickly. So uh, when I have conversations with my peers, many of them are scared about AI because they're afraid that it's going to take their job in the future. And I will say I'm not afraid of that at all, because it's going to be, in my opinion, it's going to be the opposite instead. It's going to enable more software to be built, more things, more products to be created. And it's one of those moments like when the cloud was invented, when other different technologies were invaded software, and people were scared. Oh my God, how do we do now? Instead, I see AI as a way to amplify your impact, your value, and it can allow people to vibe code something in Replit in a few hours, who have never touched code, but it can also allow professionals to write real code that should not fail, that is production grade. So it can do both much faster. I am very excited about what's going to come in the next few years. So it's not going to take your job.
Skeptic to optimist.
Yeah, skeptic to optimist. It's one of my favorite transformation stories. Thank you all so much for being here. Angelo, thank you so much for being our featured guest and sharing your whole journey from beginning to end and for working with us. Josh, thank you as well for representing Resolve AI. To each of you, we will share out the recording. This will also be posted online. Come see us anytime. We have in-person builder meetups at our HQ and SF. And if not, find some on-demand content. Go follow Angelo and Josh. They're constantly talking about things they're learning, and just really appreciate your emphasis on developer and customer success to both of you. So hope to see you soon, and thanks all.